Hello, in today's lesson we're looking at solving right triangles. Our objectives are to solve a right triangle and use right triangles to solve real-life problems. Vocabulary. Solve a right triangle. To solve a right triangle means to determine the measures of all three angles and the lengths of all three sides. Before we start the note-taking guide, I want to go over how to find angle measures given side lengths. This information is not in your note-taking guide, so please make sure you put it on the side of your notes or somewhere where you can find this information. If we are given a right triangle where we have at least two of the sides and we are asked to find the angle measure of that right triangle that is not 90 degrees, then what we can do is we can create a trig operation that is the inverse of whatever information we're given. What I mean by this is in this example, I have to find angle A, which they've labeled X. In order to find X, the first thing I'm going to do is look at the information I'm given and see how it relates to angle A. So I'm given this measure over here, which is 15, and in relationship to angle A, 15 is my opposite side. I'm also given 20, and in relationship to angle A, 20 is my adjacent side. So thinking back on my trig functions, I have opposite and adjacent. That is my tangent function. So I can write a proportion where I have tangent of angle A is equal to opposite over the adjacent, and then fill in what I know and what I'm looking for. I'm looking for tangent of X, which is equal to 15 over 20. Simplify this ratio, you get tangent X is equal to 0.75. From here, to find our angle measures, we're going to do something called the inverse functions. Normally above your calculator where it says tangent, you'll see this that says tangent inverse or tangent to the power of -1. That means tangent inverse. Depending on how your calculator works, sometimes you'll press the second or shift button and then your tangent inverse, or sometimes you might press the tangent button and then press your shift or second button. Either way, what you would do is you would take the tangent inverse of 0.75 and you would end up with angle X is equal to 36.87, or if you round it, approximately 37 degrees. Alright, example 1, solving a right triangle. Solve the right triangle, round decimals to nearest 10. In this right triangle over here, I am given two side measures. I don't know the angle measure, so the first thing I can do is I can use the Pythagorean theorem to find C, which is my hypotenuse. I know it's my hypotenuse because it is across from the right angle over here. C square is equal to the leg square plus the leg square. One of my legs is 4 and the other leg is 8. 4 square is 16, 8 square is 64. Add those together, you get 80. Take the square root of 80, and when I take the square root of 80, I'm going to simplify it. So that is 2 goes into 80 40 times, 2 goes into 40 20 times, 2 goes into 20 10 times, 2 goes into 10 5 times. The next prime number I can divide 5 by is 5, which gives me 1. Every time I have a pair, I take one out, I get rid of the other, so this is 2 times, take one out, get rid of the other, 2. What's left goes back in the house. Simplify that, that's 4 square root of 5. You can also go ahead and plug the square root of 80 into your calculator, and you get that C is approximately 8.9. Once we find that, let's go ahead and now find an angle measure. You can choose whether you want to find angle A or angle B. Since our example is finding angle B, that's what we're going to do. I'm going to look at angle B, and with relationship to angle B, I am given this side, which is the opposite, and I'm also given this 8, which is my adjacent in relationship to angle B. So I know that opposite and adjacent is the tangent function. So first I'm going to find the ratio of the tangent, which is 4 divided by 8. Then I'm going to plug it into my calculator and do the tangent inverse of 4 divided by 8. And I'm going to get that angle B is approximately 26.6 degrees. By the way that I would set this up is I would say tangent B is equal to opposite over adjacent, and tangent B is equal to 4 over 8. Angle B is tangent inverse of 4 over 8. Once I find the measure of angle B, I know that A and B are complementary angles and their sum is 90 degrees. So I can find that the measure of angle A plus the measure of angle B is equal to 90 degrees. I know the measure of angle B is 26.6. Solve for A by subtracting 26 24.6 on both sides, and you get the measure of angle A is 63.4. Answer is the side lengths are 4, 8, and 8.9. The angle measures are 26.6, 63.4, and 90 degrees. Example 2. Again, we're solving for a right triangle. Now, in this case, we are given a side measure and we're given an angle. So we need to find two side measures and another angle. The first step is let's go ahead and find the side measures. We start by finding the side measure of Q. With relationship to angle Q, I am given side Q is its opposite. And what I'm given is this length over here, 30, which is across from my right angle. So that is my hypotenuse. I know that opposite over hypotenuse means I'm using the sine function. So I can write sine of angle Q is equal to the opposite over hypotenuse. Go ahead and plug in what I know. Sine of 53 degrees is equal to Q, which is the opposite length, over my hypotenuse, which is 30. Cross multiply to isolate Q, and I get Q is equal to 30 times sine 53. Sine of 53, when you plug it into your calculator, is 0.7986. Multiply that by 30, and you get that Q is approximately 24.0 units. Now that we found side Q, we can go ahead and find side P. One of the ways we could find side P is we could use the Pythagorean theorem to find side P. I prefer, whenever possible, to not use values that I have computed, because if I had made a mistake over here with side Q, that means side P would be wrong. So I try to always use measurements that I'm given in order to find the unknown. So in this case, I'm going to look for side P. Again, with relationship to 53 degrees, angle Q, side P is my adjacent. And what I'm given is my hypotenuse, which is 30. I know the trig function that uses adjacent and hypotenuse is cosine, so I can set up a ratio of cosine Q is equal to the adjacent over hypotenuse. So we've got cosine of 53 degrees is equal to side P over 30. Cross multiply to isolate P, we get 30 times cosine 53. Cosine of 53 degrees is 0.6018. Multiply that by 30, and we get that P is 18.1 units. Now we know the side lengths of this triangle. Let's go ahead and find this last angle over here, angle P. We know that angle P and angle Q are complementary. The sum of their measures is 90 degrees. The measure of angle P plus the measure of angle Q is equal to 90 degrees. We know the measure of angle Q, that's what we're given, that's 53. Subtract 53 on both sides, and we get the measure of angle P is 37 degrees. So the side lengths of our triangles are 18.1, 24.0, and 30. The angle measures are 37 degrees, 53 degrees, and 90 degrees. Alright, checkpoint problems number 1 and 2 are yours. For each of these problems, you are to solve the right triangle and round decimals to the nearest tenth. Remember, to solve right triangles, you have to find all angle measures and all side measures. Example number 3. Again, we are solving a right triangle, but this is in relationship to sports. When a hockey player is 35 feet from the goal line, he shoots the puck directly at the goal. The angle of elevation at which the puck leaves the ice is 7 degrees. The height of the goal is 4 feet. Will the player score a goal? Essentially, what the question is asking is, when we extend this line over here of the trajectory of the puck, will it go above the goal or will it actually go inside the goal? So what we need to find is the final height of the puck once it's past that 35 feet. So I know over here this measure is 7, the angle. I know I need to find the height after it's past the 35 feet. Looking in relationship to this angle that's 7 degrees, I have this length over here, which is my opposite. So my height's my opposite, and what I'm given is my adjacent, which is 35. The trig function that uses opposite and adjacent is tangent, so I know that tangent of 7 degrees is equal to opposite over adjacent. Plug in what I know. Tangent of 7 degrees is equal to the height over 35. Cross multiply to isolate the height, so I get 35 times tangent of 7 is equal to height. Tangent of 7 degrees is 0.1228, which we're going to multiply by 35, and we get that the height is approximately 4.3 feet. Because the height of the puck at the goal line is 4.3 feet, which is greater than the height of the goal, which is 4 feet, the player will not score a goal. All right, checkpoint problem number 3. A hockey player is 27 feet from the goal line. He shoots the puck directly at the goal. The height of the goal is 4 feet. What is the maximum angle of elevation at which the player can shoot the puck and still score a goal? So basically in this example, you need to find the value of x. All right, that's it from me. I'll see you all soon.